Hi guys, in this video I want to finish up section 2.4, and the way that we're going to finish it up is by talking about an application of linear graphs and also to note or to determine when a given equation is a linear equation or not. So let's begin just by reviewing some stuff. So linear graphs can take kind of four of the following forms. You've either got a horizontal line, y equals 2, let's say, where you have zero slope. You have vertical lines where you have an undefined slope and they're of the form x equals a number, x equals 2, say. And then you've got these two other cases, one where you have a positive slope where it's increasing as you move toward the right, or with a negative slope, which means that your function is decreasing as you move to the right. So now, why don't we take an example. Let's say that we buy a phone for $200 and that the phone plan separately costs $50 per month. And what we want to do with this is we want to create a linear model to model this situation, and then we want to answer two questions with this model. We want to use this model to determine how many months it would take to incur $300 of cost, and also how much this plan costs for a year. So let's do this. So first, let's begin by thinking about how we create the linear model. Well, our linear model is going to be something of the form y equals mx plus b. So I'll write that first, mx plus b. And in this situation, b is like a fixed cost. It's what you pay up front, or I'll say up front. And then m is your variable cost. This is how much you pay, so this is variable cost. It depends on how many months that we're using the phone for. So this is the variable cost m, and b is the fixed cost, the upfront cost. So in this particular instance, the variable cost I'll underline in blue. So variable cost corresponds to this $50 a month here. It depends on how many months that we have the phone for. So that's the variable cost. And then in green I'll highlight the fixed cost. So the fixed cost, your b, is up here. That's the 200. So we're going to fill in all that information now. So our model will be y equals, m here is 50x plus our fixed cost, our upfront cost of $200. So this is the given model for this situation. And now what we want to do is we want to answer the two questions pertaining to this model. The first question was asking us how many months. So remember, x is months and y is the cost in dollars. So I'll just say cost. So what we want to do now is we want to determine how many months it would take to incur $300 of cost. So here's what we do. We're given $300 as the cost, so that's what we're going to plug in for y. So maybe I'll label what these questions are. So this is like question 1, how many months it takes, and then question 2 is how much it would cost for the year. So let's talk about question 1 down here at the bottom. So question 1, how much would it take to incur $300 of cost? So we let y be 300. That's the cost is y. We're letting that be 300, and then we're solving this equation for x. So the first thing we'll want to do is we'll subtract 200. After subtracting 200 from both sides, we get 100 on the left side. And then on the right hand side of the equation we get 50x. Therefore we can see that after dividing both sides by 50, we get that x must be equal to 2. So x is 2 months. In other words, we spend $200 right away when we get the phone, and then after 2 months, 2 times 50 is 100, so we add that 100 on, and then we end up getting $300 of cost after 2 months. Now, what we want to do is we want to determine how much this plan costs for a year. So we know that a year is 12 months, so we know in this case that X, for question 2, X is 12. We're going to plug that into our model, and then we'll use that to determine how much the plan will cost in dollars. So we plug in X equals 12, and we'll get Y of 12 is 50 times 12 plus 200. 50 times 12 is 600 plus 200, which gives us $800 total. So this phone plan will cost you $800 for a year. All right, so that's it for this video. We went over a linear model, and we talked about some linear graphs. I think this wraps up section 2.4. I was going to talk about how we recognize when a given equation is linear, but ultimately, if it's any of these cases, that's when it's linear. It's when the slope is constant. As we move to the right, we're adding the same amount to our y value. The slope is constant. That's what characterizes lines. Yeah, that's it for this video. We'll see you guys in the next one. We're starting section 2.5. And in that video, we'll cover point slope form and some applications of that. So see you in the next one, guys. I hope you enjoyed it.